With this small video animation, we would like to demonstrate how street lighting can be supplied with power by using power cube technology, completely independent of any public power grid or diesel-powered generators. Neither is needed anymore. We have created the following scenario: a road with everything that goes along with it. Our main focus is on the street lights, in this case shown as LED lights, which will illuminate our road later on when it gets dark. In order to ensure that the electricity also reaches the street lights, we are using a feeder pillar. From there, the individual cables go to the street lights. These cables are laid underground, in example buried in the ground. That's why you don't see them, and that's where they are best protected, for example from ambient weather conditions, rodents or other possible damage. The electricity must therefore be fed into the feeder pillar to ensure that the lights are being switched on at night. On the right hand side we have the photovoltaic panels that convert the light coming from the sun into electricity. The location of these photovoltaic panels is only a symbolic representation. The photovoltaic doesn't necessarily have to be right next to the power cube. It may as well be attached on the roof or to the sides of the power cube, which the white container in the middle, we will get to that later. It may likewise be up to 50 meters away, just according to individual local conditions. As said before, this is the power cube. Viewed from outside, it pretty much resembles a normal shipping container. What is much more interesting is what is inside. Firstly, we have a thermal insulation, to ensure it doesn't get too hot inside when the sun shines on it. In addition, we have an air condition in the interior, so that it does not get warmer than 30 degrees inside. On the right inside, we have a massive battery storage with a decent capacity. In order to visualize in our animation whether this battery storage is full, half full or empty, we applied a measuring display. This changes depending on whether the batteries are being charged, in which case they light up green, or whether they send electricity to the feeder pillar, in which case they light up red. There are 3 inverters on the left, but these are no ordinary inverters, as you may know from the solar cells in your own home. They have special skills, because they can create their own electricity network, just like that one coming from any socket. And by interconnecting several of these inverters, the required output power can be determined. In short, the more lamps, the more inverters are required. And they can do a few more things, but that would now go too much into electrical engineering details. And in the middle, we have a control cabinet, which takes care of the electricity distribution. To ensure that the electricity can actually flow back and forth, all 3 components, the battery storage, the inverters and the control cabinet, are interconnected with cables. To see when electricity is flowing, cables are changing their color. When electricity is stored inside the batteries, the cables glow green. When electricity flows from the batteries to the lights, the cables light up in red. And when there is no current flowing, for example when the batteries are fully loaded and there is daylight outside, the cables are black. Same thing applies to the cables laying outside, which are visible only in our animation. These 3 transport the electricity from the photovoltaic to the control cabinet. From there it then reaches the batteries via the inverters. And this cable goes from the control cabinet to the feeder pillar. The electricity from the batteries runs via the inverters and the control cabinet to the street lighting. It is now 10:30 AM. There is daylight outside. There is no need for any street lighting at these times, so the lights are off, and there is no current flowing through the cable to the feeder pillar. But the sun shines on the photovoltaic panels and these generate electricity. That is why the cables also light up in green, because the current takes its way through the control cabinet and the inverters, and is then stored in the batteries. And as long as the sun is shining, this process will continue until the batteries are fully loaded. At the top right of the picture you can see the current time, And if you watch the battery indicator, you will realize how the battery level goes up until the batteries are 100% fully charged. It is now 3:30 p.m. and the battery charge indicator is already at 100%. The inverters now switch off charging from the batteries, precisely because they are now fully loaded. And you can see that from the fact that the cables inside the power cube no longer glow green. Electricity would still come from photovoltaics, but when the batteries are fully loaded, this is no longer needed. And as long as it is bright enough outside, this is the way it remains, until dusk sets in around 5:30 p.m. and it gets dark. The switch cabinet, which is located inside the container, has a sensor to detect how bright is it outside. If this sensor now recognizes that it is getting dark, the control cabinet gives the command to send the current from the batteries to the lights. So now it's time to switch on the light. The inverters now take the electricity from the batteries and send it via the control cabinet to the feeder pillar. That's why it all lights up in red now, and our road lights are burning. All the time, while it is dark, the electricity is taken from the batteries. The charge level indicator on the batteries can now be watched slowly going down as night passes by. And as long as it's night outside, this is the way it remains. Until about 5:30 a.m. when dawn sets and the sun starts rising again. The whole process starts all over, only this time in reverse order. Firstly, the inverters switch off the power going to the feeder pillar. The lights goes off. Then they stand by until the photovoltaic panels get enough sunlight to supply electricity again. And as soon as enough electricity is provided from their end, the batteries are being recharged. And this cycle continuously repeats on a daily basis.